We know that generator is a device which converts mechanical energy into electrical energy, and it is based on the principle of electromagnetic induction. Electromagnetic induction. Today we are going to focus on the construction and working of generator. This is the definition. This is generator converts mechanical energy into electrical energy, and it is based on the principle of electromagnetic induction. I mentioned this in previous class also. Now, how it is constructed? Let's talk about this. How it is constructed? Actually, generator consists of a U-shaped magnet. It's like this. Generator consists of a concave pole. This is concave pole. This surface which is gone inside, this is surface, this concave surface, this concave surface, and this is a magnet having north pole and south pole. Generator consists of a U-shaped. It is U-shaped like this. When it goes down, the all part is not shown. This is concave poled U-shaped magnet. It's U-shaped magnet. And concave poled U-shaped magnet in which poles are facing each other. Look at this. North pole is facing south pole and south pole is facing north pole. A coil having an iron core is placed between the poles. Look at this. I'm going to make a coil here. Coil. Let's say this is a coil. Having an iron core, what it means? Coil having an iron core means the iron piece is placed in the middle and it is wound with the insulated copper wire, and hundreds of turns are made. I'm showing just one turn. Just for the diagram, we'll make only one turn. The coil consists of iron in its core in the central part, which is wound with insulated copper wire, and there are hundreds of turns. And this is later having an iron core is placed between the poles, and the terminal of the coil is connected to the split ring. Look at this. I'm going to make a ring here. This is ring. Now what we are going to make here, this is coming and connected to this, is coming and connected to this one. Okay, now what we understood, this coil has an iron core and it is placed between the north and south pole, and the terminals of the coil is connected to this split ring. Now there are two types of, I want to just mention only, it's not the purpose of this class. It consists of two types of ring. One is called split ring, another is called slip ring, and which are used for different purpose. Some generators are used to take alternating current as an output. Some generators are designed to collect direct current as output. Accordingly, the rings are different, but we are not concerned with alternating current and direct current at this stage. We are just talking about the construction and how it produces electrical energy. Okay, now rings are provided with brushes. Now I want to make you a little more clear, that's why using different colors. This is brush. Now what I said just now, this rings are provided with brushes. Let's say these brushes are B1 and B2, and that presses against the ring. These brushes are designed in such a way that it keeps on pressing the ring. Just for example, if this is ring and brass is here, and it keeps on pressing the ring, yeah, and it is not connected, actually pressing the ring. Brass is pressing the ring can rotate, but brass remains in its position. That's why it is designed in such a way that when ring rotated, then brass remains in its position. Okay, and the brushes take output current to the load. Look at this brushes, whenever current produces in this generator, it comes to brushes, and brushes collects it, and it takes this current to the load. This load is, let's say, this is load. This way it is designed. Actually, this is the simple representation of a generator. We can label this, let's say this is A, this corner is B, this corner C, and this corner D, and we can say that A, B, C, D, this is coil. There are hundreds of turns. Don't be confused. Just not only one turn. It is in the figure only. We are showing only one turn. B1 and B2. I mentioned this. This B1 and B2 means this. Here it is brush B1. This is B2. B1 and B2 are what? Brushes. And here this is R, ring. R is, let's say, ring. And we can say this L. Here L is what? Load. This is the construction of generator. Now I want to say again, certainly, generator consists of a U-shaped concave poled magnet in which poles are facing each other, a coil having an iron core. In the core it has iron, is placed between the poles and the terminals of the coil. These terminals of the coil is connected to split ring, or you can say just the ring also. Rings are provided with brushes, and these brushes are pressing against the ring. Brushes takes output current to the load. This is the construction. Now question comes, how it works? Now I'm talking about its working. Let's say actually in generator this coil is rotated. We can rotate either the coil or the magnet, but normally coil is rotated. When the coil of the generator is rotated, then what happens? It's cause of the magnetic lines of force of the magnet. The North Pole and South Pole are facing each other. Magnetic lines of force starts from North Pole and goes up to the South Pole this way. And magnetic lines of force are in this way. And this coil is when rotated, then it cuts like this. This way it cuts. And again it cuts this way. In one round, once it cuts this way, just for example, AB once cuts the magnetic lines of force, and then when AB goes up, then CD comes and it cuts up the magnetic line. The same AB once cuts up the magnetic line of force, same AB when goes down, it again cuts up the magnetic line of force. When the coil of the generator is rotated, then it cuts the magnetic lines of force of the magnet. According to the principle of electromagnetic induction, which was taught in previous class, when a conductor cuts up the magnetic line of force, electric current flows in the conductor. So an electric current flow in this conductor, flow in the coil, here conductor is coil, coil, which when reaches to the ring, collected by the brushes, and it is what? Collected by the brushes, and lastly reaches to the load through the conductor, reaches to the load. Thus a generator generates electricity. This way, if it keeps on rotating and rotating, what? Coil, then it cuts the magnetic line of force, constantly in one rotation twice, it causes the magnetic line of force, and because of this reason electric current flows in the conductor or this coil, and it is collected through the process, and it comes to the load. This way a generator works. Okay, this much for today.